Greetings, this is Rick Powers coming to you from my home office for Western Technical College, Introductory Statistics. And my subject today is a very important one in our area, and that is called hypothesis testing. I'm going to go through the notes so that hopefully you'll be able to understand them well. So, first question, what are hypotheses? They are not numbers, they are statements about a number. For example, the population mean is less than 57. This is a hypothesis. It can be true or false. Number one, a null hypothesis, symbol H sub 0. We assume that the population has a measurement equal to some standard number. Examples, the mean is equal to 57. The proportion is equal to 25%. Standard deviation is equal to 3.6. This statement cannot be proven true. We cannot prove equality since sample numbers are always changing. Number two, alternative hypothesis, symbol H sub A, something that we want to prove. Try to prove a difference in some direction. Examples, the mean is less than 57. A proportion is greater than 25%. A standard deviation is not equal to 3.6. This is what we want to prove. We can prove the difference if the difference is large enough. Note, some textbooks use H sub 1 for alternative hypothesis. In order to see a difference, we have to consider the tails. A left-tailed test if we're trying to prove less than, a right-tailed test if we're trying to prove greater than, a two-tailed test if we are trying to prove different from. Note, in my opinion, once we have a sample number, then we can decide which direction to look for a difference. Example, if our standard number is p is equal to 0.30 and our sample number is 0.40, it makes sense to do a right-tailed test. Textbooks do not agree with this idea. How to make a decision, called the p-value method. We choose a probability for unusual values called alpha. It's a Greek letter, alpha. Usually alpha equals 0.05. We could also say this is our accepted probability of being wrong. This is also called the level of significance. Then we use a statistical formula to find the probability of getting a sample that's different from the standard number in the null hypothesis. The formula result is called the test value, which we then use to find the area of the tail. This area is the p-value. Decision. If the p-value is less than alpha, then we reject the null hypothesis, and there is evidence to prove the alternative hypothesis. Note, when doing a two-tailed test, we add the area of the two tails to get the p-value. The strange logic of hypothesis testing. Two possible results. Reject the null hypothesis. Result, there is enough evidence to prove with a specific amount of confidence, 1 minus alpha, that the alternative hypothesis is true. There is enough evidence to prove that the alternative hypothesis is true. This is our goal. It seems strange that we want to reject something, but we have to reject the null hypothesis in order to prove the alternative hypothesis. We are not rejecting the data or anything else. Option number 2, do not reject the null hypothesis. Result, there is not enough evidence to prove with a specific amount of confidence that the alternative hypothesis true. There is not enough evidence to prove the alternative hypothesis. It is very important to recognize we have not proven the null hypothesis with this result. This situation indicates the difference that we found could have been a random change due to using a sample. The role of sample size. As with confidence intervals, if we have a large sample size, our results will be more accurate. So in a sense, if the sample size is large enough, we can prove that even small differences are, quote unquote, not by chance or significant. However, we have to have experience in using data in order to know whether or not a small difference matters or has practical significance. So then hypothesis testing doesn't actually prove something in a real life sense. It just indicates that something might be a difference that is not due to chance. We need real experience with the meaning of numbers in order to know if statistics matches reality.